In this section, we're going to learn a new method on how to solve a system of equations. So in 7.1, we graphed a system of equations to solve it. So it was a timely process. You had to graph 2 lines and then search for the point of intersection. This time we're going to solve by substitution. We've been substituting a lot this year. Substitution just means to replace. So we're going to be replacing or plugging in to find the solution. The key is that you still have to remember that when we graphed, if you were kind of picturing 2 graphed lines, you're still looking for that point of intersection. So your solution is still going to be a point. We have to write it as a point. So we still need 2 coordinates. We need the x-coordinate and the y-coordinate. So the first step to substitution is just to isolate one of the variables. It really doesn't matter which one. We've spent so much time this year isolating y, but it doesn't have to be y. You can isolate y, you can isolate x. The other thing about this step is sometimes it's done for you. So if you take a look at this first example down here, we actually don't have to do step 1 because y is already isolated. If you take a look at this example over here, we're not there yet, but you'll see that x and y, neither of them are isolated, so eventually we're going to try to find the easiest one to isolate. We'll talk about that with the things to look for. So we're going to move on to step 2, which says plug whatever this variable, that's talking about the isolated variable, into the other equation. So if you look at our first equation, that's the one that's y is isolated, so we're going to plug this in here. So the blue, what that really says is everywhere you see a y, you can substitute in its place a 3x plus 2, because that's what y is equivalent to. So what I'm going to do with this equation, I'm just going to move things around so I can make it a little bigger, is I'm going to take this y right here, I'm just going to pull it out. I'm going to pull it out because I don't want y anymore. What I do want instead is I want to take this thing that y is equivalent to, because this says that y is equal to 3x plus 2. So I want to take that 3x plus 2 and I want to put it where the y was. So just to show you that one more time. So the first equation we never changed. It was always that y equals 3x plus 2. The second equation was x plus 2y equals 11. But this tells me that in place of y, I can put 3x plus 2. So I took that y piece out and I'm going to put it off to the side. I'm just moving this over so I have enough room. And I'm going to slide that in its place. One thing we just have to remember to do is anytime you substitute, you need parentheses. So there's going to be parentheses around that 3x plus 2. So now I have this new equation that only has an x in it, and this type of equation is actually something we learned back in chapter 3. So if my goal is to solve for x, I need to start simplifying the equation. So I can distribute a 2 here. So I'm going to bring down this first x. Then I'm going to distribute 2, so I get 6x plus 4, and then I just bring down my equals 11. And I'm just going to keep going. Now at this point it's pretty natural. X plus 6x is 7x. Bring down my plus 4 equals 11. If I minus 4 from both sides, I get 7x equals 7. And then if I divided both sides by 7, I get x equals 1. So what we actually just did was we performed step 3, which was solve like normal. That's what we just did. But if you remember kind of 2 intersecting lines, if I just draw that up here really quickly, that's what we did in 7.1. We're looking for this point of intersection, because that's a point on the graph. And all we have so far is the x-coordinate. So I still need to find the y part of that. So in order to do that, what I'm going to do is find the other half of the ordered pair. And I'm just going to look at the original equation, which was y equals 3x plus 2. So I know that y will equal 3 times whatever x is, and then add 2 to it. But I know what x is. X is 1. So if I take that 1 and put it in there, I get y equals 3 times 1 plus 2, which is 3 plus 2. So y is 5. So now I have my ordered pair. I have 1, comma 5, and that should have said like y equals 5, because that should have been y equals the whole time. Now I have an ordered pair, I have an answer, I'm good to go. Okay, so on this example over here, it's a little different because step 1, I was supposed to isolate any variable, and in this one, y was already isolated. So in this example, I have some choices. I'm actually going to put colors. I can isolate the x that I just dotted in blue, the y that I just dotted in black, the x in red, or the x in green. So what we want to figure out is of these 4 variables, which one would be the fastest to isolate, the easiest to isolate, the fewest amount of steps, and if possible, not get us any fractions or decimals. So if you look at y, if you wanted to isolate the black y, you'd have to minus x and divide by -2. So it's a two-step process, but not only that, you'd be dividing 1x by -2. You're going to get a fraction. It is possible to do that, but I wouldn't. So then let's look at 4x. If I wanted to isolate the x here, you would have to minus 6y and then divide by 4. So you would end up dividing a 6 by a 4, you'd get a fraction, and it was a two-step process. If you want to isolate the green y, you have to minus 4x and then divide by 6. So again, a two-step process, and you'd be dividing these 4's by that 6. You'd get a fraction again. If you look at the blue x, to isolate the blue x, all you have to do is bring over the minus 2y by adding it. So the easiest thing to isolate in this problem, I'm going to rewrite this equation over here, x minus 2y equals -6, and we're going to isolate x by adding 2y to both sides. So now we know that x equals -6 plus 2y. The reason x was so easy to isolate was because it had a coefficient of 1. So that's one of the things I want to write up here. Things to look for, coefficient of 1. Because if something has a coefficient of 1, all you have to do is add or subtract the other piece. The other thing I'm going to say is divisibility. And what I mean by that is if something didn't have a coefficient of 1, like here the coefficient of y is -2, so you'd be dividing by -2. Here you're dividing by 4, here you're dividing by 6. If you had 4 situations without a 1, what number would you be dividing by? And you'd want to divide by the number that gave you either no fractions or the fewest fractions possible. Thankfully we didn't end up with that here. Alright, so back to this problem. So I have used this first equation right here I've used this one right here to isolate my variable. So that means now I've got to use this second equation, the 4x plus 6y equals 4, to actually figure out one of my variables. So I have 4x plus 6y equals 4. That's just the second equation, no changes. But what the first equation tells me now is that everywhere I see an x, I can remove it. And instead of writing the variable x, so I have 4, I'm going to leave that blank, but when I leave it blank, I'm going to put it in I'm going to put parentheses. So that's the second equation rewritten just with x removed. You can see x disappeared. And this says that inside that parentheses, I can write -6 plus 2y, and that was a y. So in here I'm going to write -6 plus 2y. Now I'm going to solve that like normal. So to do that, we would just distribute, and you get -24 plus 8y. Bring down the plus 6y equals 4. Combine like terms, -24 plus 14y equals 4. Now it's time to isolate y, so we gotta get rid of that -24, so we'd add 24 to both sides, so 14y equals 28. Divide both sides by 14, y equals 2. But again, our answer is an ordered pair. We only have half of it so far. I'm still missing the x, so I at least know that the y part of my ordered pair is 2. So to find x, I'm going to take that, I'm going to plug it right in there. Because I know that x is going to be -6 plus 2 times whatever y is, but that's 2. So x equals -6 plus 4, x equals -2. So there's 4 examples here for you to try. Give them each a try, pause the video, press play when you're ready to check your answers. So in this first example, I chose to isolate the top y only because it came first, and all you had to do is minus 2x, so y equals 5 minus 2x. I could have just as easily as I have isolated that one, but since this equation came first, that's just what I started with. So then I rewrote the second equation here in blue, but when I got to y, I just left empty parentheses, and then I slid this 5 minus 2x in its spot. There's nothing outside multiplying it, or you could think of it as a 1, but 1 times anything is itself, so I actually just drop them. 3x minus 2x is 1x, and then I have plus 5, 10 minus 5 is 5, so the x coordinate is 5. Then you just take that, and you plug it right in there, because y is going to be 5 minus 2 times whatever x is, but we know x is 5. So 5 minus 10 would be -5, you write your final answer as an ordered pair. Over here, the easiest variable to isolate was x, because you just had to add y. So x equals y plus 3. Here's my second equation written, but where x is, I left empty parentheses, and then I slid in y plus 3. Again, there's nothing being distributed, so you can just drop it. So then y plus 2y is 3y. Negative 6 minus 3, because you get rid of the 3 by minusing is negative 9. Divide both sides by 3, y is negative 3. Then you take that and you just plug it in right there to find x. Negative 3 plus 3 is 0. And you write your final answer as an ordered pair. Over here, easiest variable to isolate was y in this first equation by minusing 3x. So y equals negative 7 minus 3x. Here's the second equation with the parentheses where the y goes, and then that just slides in its spot. Distribute a 4. So 4 times negative 7 is negative 28. 4 times negative 3x is negative 12x. Negative 2x and negative 12x combine to negative 14x. To move the negative 28 to the other side, you would add. So you have a positive 28. Divide by negative 14. X is negative 2. Plug that in for x. Negative 7, that's 2 negatives, so it becomes plus 6, and you get negative 1. So negative 2, negative 1. In the last example, y is already isolated, so that just means that in this second equation, in the parentheses, you can put 2x minus 3. That becomes a 6x, that becomes a minus 9. X plus 6x is 7x. To get rid of the minus 9, you would add. 5 plus 9 is 14. X is 2. And here it says y is going to be 2 times whatever x is, which is 2, so that's 4, and then minus 3. So 2 comma 1.